This is Mrs. Halley with 8th grade lesson 1.2 over rational and irrational numbers. And the goal for today is I can understand the differences between rational and irrational numbers. Now we're actually going to be looking at 4 different distinctions of numbers. They can be separated into rational numbers and irrational numbers. But under the rational numbers category, there are a few more specific categories. So vocabulary. A rational number is any number that can be expressed as a fraction. So whole number, fraction, decimal, percent, those are rational numbers. Now within that, there are 2 subcategories. Integers, which are whole numbers and their opposite, so just positive and negatives, but not decimals, not fractions. And then there's whole numbers, which is all positive numbers and 0. So those are rational numbers. An irrational number is a number that cannot be expressed as a fraction. And if it's changed into a decimal, it never ends and it never repeats. It just goes on and on and on, and there's no predicting it. If you have a person that is acting irrationally, you can't predict the way they're going to react. An irrational number, you can't predict what the number is going to be. So here are an example of rational numbers. So 16, which is also a whole number and an integer. We would categorize it as a whole number. That's its most specific. 1/2, 3 and 56 hundredths, because that can be written as 56 over 100. -8, which is also an integer. That's where I would categorize it. 1.3 repeating, because that can be written as 1 1/3. And then -3/4. Here are the irrational numbers. So we have the square root of 20, which comes out to be 4.47213594. It just keeps going and going. There's no pattern. It's not a perfect square. Pi, 3.14159265. It just keeps going and going and going. Pi is an irrational number. And finally, even though this last one, the square root of 3 over 2, is a fraction, the square root of 3 is an irrational number. It does not come out to be a perfect square. So we would say this entire thing is irrational. So we're going to look at these and we're just going to practice sorting. So 1/2, it's a rational number because it's a fraction, but it's not whole, it's not an integer, so it goes here. The cube root of 8 is equal to +2. That is a whole number. Now it's also a rational and also an integer, but because it is a positive whole number, I categorize it as a whole number. Same with the square root of 16. Square root of 16 is 4. It works out perfectly. It goes in the whole numbers category. 3, however, is not a perfect square. 3 does not work out perfectly. It's going to give me a weird repeating decimal, a weird decimal that does not end or repeat. It's irrational. 15 over 3. 15 over 3 is a fraction, so I automatically know it's rational. But 15 divided by 3 gives me +5. That actually lands in the whole numbers category. -8. It is a whole number, but it's a negative. Negatives belong in the integers column. 0.63 repeating. It is a decimal, but it repeats. There's a pattern to it, so it's rational. Pi, that's irrational. It goes on and on and on forever with no pattern. 1/3 is a fraction, but it is not going to end up equaling a whole number like the 15/3. So 1/3 actually belongs in the rational numbers category. 0 is a whole number. Oh, and I can't move it. I've done something to it. There we go. 0 is a whole number. And finally, the cube root of 25. The square root of 25 comes out to be 5. Cube root of 25 falls somewhere in between 2, which 2 times 2 times 2 is 8, and 3, because 3 times 3 times 3 is 27. It's not perfect, so it belongs in this irrational column. So you can see in the whole numbers, it's our positive whole numbers and 0. Integers, it ends up being all negative numbers because, well, the whole numbers take all of the positive whole numbers. Rational numbers, fractions, decimals that repeat, percent. Irrational numbers are the weird ones. They're the square roots and cube roots that do not come out perfectly, and then special numbers like pi. Now we'll spend some more time on this tomorrow.